Let's go over some notes on section 5.4, which is a review of linear inequalities, not just, open circle arrow going one direction. These are linear inequalities, so we have x and y. So if you recall from Algebra 2, when we get to graphing, basically you just graph the boundary line, and sometimes we do dotted, sometimes we do solid. That sound familiar? And then you shade either above or below the line based on what we call the 0, 0 test. So let's dig in and see how this works. A linear inequality is in two variables, and it's an inequality that often looks like ax plus by less than or equal to some constant c. All right, and these are all real numbers, and b cannot be equal to 0. Okay, we need two variables, so that's why b cannot be 0. So first of all, a solution to anything is a number or a combination, in this case an order pair that works, that gives a true statement when you plug it in. So let's come down here and let's plug in 4.1 or 4 comma 1, and let's see if it works. So we're running a little test here. So we're going to plug the y in for y. Remember, y is 1 and x is 4 according to this. Make sure you get those in the right place. Common mistake is to get those switched around, you can imagine. So 1 is greater than or equal to. Now I'm going to put a big fat question mark here, but just to remind you that we're running a test. We're not sure if this is going to be true or not. We're going to see. Now, what is negative 2 times 4? Well, that's going to be negative 8. So 1 greater than or equal to question mark, sorry about the clock, negative 8 plus 1. So if we come up here, then that would be 1 is greater than or equal to negative 7, question mark. Now, is that true? Well, let's think about the number line. Here's 0, here's 1, and over here is negative 7. So we're comparing this point to this point. Is the alligator eating the bigger number? Is 1 bigger than or equal to negative 7? Yes, of course. It is. So the answer to this is yes. 4, 1 is a solution to that inequality because we got a true statement. We got 1 is greater than or equal to negative 7. Let's try another combination just real quickly. Is negative 1, 0? A solution. So let's plug that in. 0 greater than or equal to negative 2 times negative 1 plus 1. Is 0 bigger than or equal to 2 plus 1? Is 0 bigger than or equal to 3, question mark? Is that true? No, of course not. So no, that's not a solution. So here we have an example where one of them worked and one did not. So the one that worked we call a solution to the inequality because, again, it worked. And then negative 1 is not a solution because it did not give a true statement when we ran it through the test here. So let's skip down here now to actually graphing. I want to do this problem first because I felt like this is probably the easiest out of the 3 that we're going to do. So there you see it in ax plus by less than c form. Now I'm going to rewrite it by minusing 2x on both sides. Perfectly legal move. We've talked about this before. I'm going to minus the 2x to the other side. No big deal. Now, step 1 is, and we're going to graph this, okay? Remember, graphs are a way to show where all the answers are. So once we get this graph done, we'll be able to answer lots of questions about, is this a solution? Is this a solution? We can do that with great ease when we have the graph. Step 1 is we do a boundary line. And it's going to be the line y equals negative 2x plus 1. Now, back in one variable inequalities, we would do an open circle whenever we see the less than sign. Remember the open circle when we did not have the equal sign? Well, what we're going to do here is we're going to be drawing a dotted line, which is similar to that open circle concept. So let's graph the line by going up 1, put a dot, right? That's the y-intercept. And then the slope here is negative 2. That means down 2, and then always go to the right if you want to be right, is what I like to say. So we're going to start here. We're going to count 1, 2 down and always go to the right. Remember, negative slope lines are always downhill, so that makes sense that it's going to be this way. And don't forget, we're going to draw a dotted line because the original question did not have an equal sign. It did not have the little bar. It did not have the little bar under there, right? It's an open circle concept. Now, we're going to shade. Step 2, we're going to shade by doing the 0, 0 test. So we're gonna see, hey, is 0, 0 a solution or not? So let's plug 0, 0 into this guy right here. 0 less than 0 plus 1. Is this true? Oops, I'm sorry, you can't see it. Is 0 less than 1? Why, yes, it is. 0 is less than 1, isn't it? So this is true. So we're going to come over here to where 0, 0 is, and I'm going to put a little smiley face here because we just discovered that 0, 0 is an answer. It's called a solution. So wherever that is, wherever the smiley face is, there must be lots of other happiness going on, right? We've got a little party going on this side of the line, and we discovered that because 0, 0 was a smiley face. It was a solution. So therefore, all the frowny faces are over here, by the way. So what does our graph look like? Our graph is not going to be a bunch of happiness, although we're pretty happy when we get it right? We're going to shade on this side. We're going to shade where all the smiley faces are. Now, in this case, remember, 0, 0 worked, so we got a smiley face on this side, so that's why we shaded. What if this had been switched around and this had been false? Well, then we would have had smiley faces on the other side. We would have recognized that 0, 0 was actually a frowny face, so we'd have to shade above the line in that case. Okay, so if this had been false, but it wasn't, it was true. If it had been false, we would have shaded the other way. Let's do another problem up here. X minus y less than or equal to 2. So first thing I'm going to do is to get it in y equals mx plus b form. So I'm going to move that x to the other side. Remember, it becomes negative when it jumps over to the other side when you minus x on both sides, right? It becomes negative. And then I'm going to divide everything by -1, dividing everything by -1. Now, a little alert symbol ought to go off in your head. That's what happens to me. Whenever you multiply or divide an inequality by a negative, you have to flip the sign around, flip the inequality around. So I went ahead and did that. So here's my linear inequality that I'm going to go ahead and graph. I'll do this one a little quicker here. We're going to have the y-intercept is down to put a dot. The slope is 1 over 1. So we're going to go up 1 over 1. Now, I want you to notice that this one does have the equal sign this time. It has a little bar under there. So we're not going to do a dotted line. We're going to do a solid line this time. So there's my solid line. Now let's run the 0, 0 test. I'm going to come over here. 0 minus 0. Again, big fat test, so I'm putting the question mark. Is 0 smaller than 2? Read that. Is 0 less than or equal to 2? Why, yes, it is. So once again, 0, 0 worked. So that's where the party's going on, is wherever 0, 0 is. In this case, it happens to be above. So I'm going to shade above. How cool is that? Also, I'll give you a little shortcut. You ready? Listen up. This doesn't always work, so you need to listen carefully. When y is solved all by itself, like it is here, a greater than means you shade up. If y is by itself and we have a less than symbol, we do on number 2 here too, we shade down. So that's a nice little shortcut, but it only works if y is by itself. See, you actually would have gotten it wrong up here if you had used that guy, because that is a less than symbol, so some students might accidentally shade below. Just make sure you solve for y first, and then you would shade up. Okay, we have one more graph to do, and then we are done. Now, this one does have a little twist in it, so make sure you're paying attention. This is already in y equals mx plus b form. It's got a 0 for a y-intercept. I don't know why I wrote 1 there at first. So it's got a 0. So I'm going to go up 0, put a dot. The slope is 3, so I'm going up 3, put a dot, right? 3 over 1. I draw my, is it solid or dotted? Let me listen. Solid, solid? Solid, good. So solid line because it has the equal. Sweet, there it is. Now, we can't run the 0, 0 test here, people, because the 0, 0 is on the line. 0, 0 is on the line. So let's see, can we use our little shortcut? Is y solved all by itself? And it is actually. Now this says y is under the line. We're looking for all the y values that are under the line. Under would be down here. So we're going to shade below the line. See how that nice little shortcut works? So we didn't have to do an actual test to figure it out. Okay, that's all there is. A quick review of linear inequalities. Hopefully you found this video useful. All right, good luck on your assignment.